All right, finding derivatives with the limit definition, section 6. Let's go about doing this. So, our equation, there's like two different ways this looks. So there's first the way with delta x. This is the way your book does it. So the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Yeah. The other way this looks commonly is with an h instead of the delta x, and this is the way it tends to show up more on the AP test. So as you're preparing for the AP test, you're probably going to start seeing h's and stuff. It's so inconsequential that they look like this. But what do these equal? Because this is just an expression. These equal the derivative at x. So this is like actually really useful because we can find the instantaneous slope at a point using this limit equation and this limit equation, since they're the same thing. Before we get too far, this equation looks all horrible. It looks like something you gotta memorize, but like I just got back from summer break, like school hasn't even started yet when I'm recording this video, and I was able to remember this because I know how it works, and it just is slope equation. If we look on a graph, we're trying to find the slope of some function, like here, at x. That's the x value I chose. That's the one we're trying to find slope for. And we're scooting forward a little bit because we're just going to find the average rate of change between those 2 points. This is average rate of change, y2 minus y1. And the change in x, which is what delta x means, is x2 minus x1. And then all we're doing is making the change of x, so the difference between our x value point here and the point that we're using for our average rate of change, we're zooming that in so that it approaches 0. And that's why we have the limit as delta x approaches 0. So if you understand how that process works, you don't actually even have to memorize this, because you should know the slope equation and you just plug this stuff in. Okay, so let's actually solve this problem now. So our function is x squared plus 2x minus 1. And yeah, f of x plus delta x means everywhere there's an x, we plug in an x plus delta x. So we're going to get x plus delta x squared. And I'm going to use this equation. It really doesn't matter which one I use, they're the same. Plus 2x plus delta x minus 1. That's f of x plus delta x. Now I'm going to do the minus f of x part, which is just our function, which is minus x squared minus 2x plus 1. It's minus the whole thing, so I just multiplied it all through by a -1 and tacked it on here. All right, and then our bottom is just delta x. That part didn't change. Now why can't we evaluate this right away is because we still have this limit as delta x approaches 0. And we can't have 0 on the bottom, so we need to find some way of canceling out the delta x with stuff on the top before we can finish this problem. All right, next step is we got to distribute here. We always have to do parentheses first in order of operations. And we get x squared plus 2x delta x plus delta x squared out of that. And then we have to distribute here, and we get 2x and 2 delta x. And then this stuff's all good. So the -1 and the +1 actually kill each other right now, and we just get minus x squared minus 2x. And all over delta x, I might as well like write all the things. Okay, now we have some beauty going on here because some things go away. X squared minus x squared. 2x minus 2x, and all we're left with is these 3 terms. Okay, so I'm going to rewrite that. 2x delta x plus delta x squared plus 2 delta x all over delta x and our limit. So we still haven't crossed out our delta x yet, but this is the step where we get to do it. All these terms have delta x, so we can divide each one of them by delta x. And so we lose one of these, we lose the squared there, and we lose this too. So now I'm going to go down here. Limit as delta x approaches 0 of, well, here we have 2x plus delta x plus 2. And now we can totally plug in the delta x as 0 into our limit. So the limit thing can go away. We can plug in 0 for this, and we get 2x plus 2. And boosh, that's our answer, which is also the equation for the slope of this graph at any point. So this is a really powerful equation. We don't need to use any calculator. We can just kind of like go through the algebra and be like, boom, I know any slope on this equation. So pretty cool. If you want to see more examples, I have a link to a YouTube video here that has another example, and I also have more examples on UC Davis's site that have more problems like this. But yeah, it's a pretty simple process. There's a lot of algebra, but if you're comfortable with the algebra, none of the new stuff is that tricky. All right, later.